Good morning, everyone. This is Shauna, and I'm coming to you today with another homework help video from section 4.5. We'll be looking at another one of the probability problems and using the combinations to solve that. So let's take a look at the question that we have before us. And the question that I've chosen for this video is number 3 on your homework. 6 men and 7 women apply for 2 identical jobs. If the jobs are filled at random, find the following. And we have 4 parts. 6 men and 7 women apply for 2 identical jobs. We want to find the probability that both are filled by men. Okay, so here we want to look at, let's do this like this. I'm going to move. Okay. Share my screen. So in this case, again, we split the problem. So this is problem 3 and this is 3A. So we're looking for six men. There's 6 men. There's 7 women. Okay. There's 2 identical jobs. 2 jobs. And we want both in part A, we want both to be filled by men. So what we're going to do here is we're going to say, remember, the probability of an event is equal to, in general, the number of ways for that event to occur divided by the number of outcomes in the sample space. Now, as I mentioned previously, in this section, the number of events in the sample space is too many to count by hand. That's why we use the combinations, the counting rules to help us. So here we're going to say this. We're going to say the probability that both are filled by men is going to be equal to, is going to equal the number of ways that 2 men can be chosen from the group, right? We're going to divide that by the number of ways to choose 2 people. Okay. So if I need to fill 2 men, that means I need 2 men and 0 women, right? So you have to choose the men from the men here. Both are filled by men. And usually she wants to see both groups. So even if both groups don't apply, and there's a reason for that in terms of the pattern of the math, it doesn't change the answer, but it does emphasize the pattern. So here we want 2 men. This is 2 men and 0 women. So from the men, which is 6, right? We want to choose 6 choose. Actually, I should probably do, okay, let me do this instead. So 6 choose 2. Okay. 6 choose 2. And 0 women, so we want 7 choose none. So this means, actually, let me write it below it. This means 2 men, and 0 women, right? Okay, now the bottom part of this is going to be the number of ways to choose, and I misspelled choose up here. Let me fix this. Let me do this here. So this is equal to the number of ways to choose 2 men over the number of ways to choose 2 people. So we have this. Now, how do we choose 2 people? Well, we have to know how many people we have, right? So what we're going to do here is we add 6 plus 7. Let me put a note up here. This is 6 plus 7, which is 13 people. Okay, men and women together. So here we get, this is going to be This is going to be 13. There's 13 people. And out of that 13 people, we're choosing 2 people. And then we could proceed as normal. You've seen me do this on the other videos. If you've seen them, you've watched the other videos about it. But let's go through it and let's see what we get. So here, let's do this. We're going to okay, so here we have. Now, I've been doing this individually. I'm going to put it in all at once just to show you that you can do that. So here we have, we're going to use a parenthesis for the top. We're going to say 6, then math, probability, NCR, number 3, 6, choose 2, and you're going to multiply that by 7, choose. So math, probability, NCR, which is number 3, 6, choose. 7, choose none. We're going to close a parenthesis. We're going to divide that by open parenthesis 13, because remember there's a total of 13. Whoops. Not the logarithm. That was a mistake. Let's see. We're going to delete that logarithm. 13. Choose. So math, probability, NCR 3. And we're choosing 2 people. Okay. And when we do that, we get 0.1923. Okay. So now if you want the fraction, you're going to have to, I'm going to go ahead, and if you want the fraction, you're probably going to have to change your mode to float, or you're going to get the individual numbers and plug them in. I'm going to see if I can make it. Give it to me here. There's my decimal. Okay, math, convert to frac. Whoops, math, convert to frac. 5/26. So this is a 5/26 probability. So let's go back here. Going to move my so I'm not sure which form the answer she has on the key, but let's take a look. This is problem number 3. Yeah, 0.192. So she rounded this to 2 places. So we have the following. Let's do this. We get this is equal to 5/26, and you know the drill by now. So this is 5/26. And then you end up with equals 0.1923, which then becomes 19.23%. Okay. So that's part A of the question. All right. Now, this preliminary work up here is just to kind of help you take notes. Now, so this is, let's do part B of the question here. So let's go back to our, worksheet. Part B says, let's go back. Part B, the probability that both are filled by women. Both are filled by women. So here we're going to do the following. We're going to say that we're going to do part B. And once again, we know so we want the probability that both are filled by women, okay? Which here we've got, this is going to equal the number of ways for 2 women to be hired, right? So remember, we can only hire the women from the group of women. All right, you can only select from the group of women. But here on the bottom, this is the number of ways for 2 people to be hired. Okay. So let's do this. We have the probability that both are filled by women. Now, let's look at this. This is going to be the number of ways to hire 2 women and no men. So let me remind you, back here, we have 6 men and 7 women. So from the 7 women, we're hiring 2 of those. So here we get, whoops, not time for that yet. We get so we have from the 7 women, let me draw this on the screen. So from the 7 women that we have, we choose 2. 7 choose 2, right? And from The 6 men, we don't choose any. 6, choose 0. Okay. So what this is we have, let me write it below it. This is almost the opposite of what we did earlier. This is from the 7 women, choose 2, and from 6 men, choose none. That's what this choose 0. That's what this actually is saying, and that's what we want. And then from the 13, we want to choose 2. So we're going to say, we're going to take that term and we're going to divide it by our very familiar 13, choose 2, right? So this is going to be, let's do this like that. We're going to say 13 choose 2. So once again, we're going to put this in the calculator and do our thing with the fractions, okay? So let's go to the calculator now. Now, I'm going to show you a little trick that you can use that might help some of you. If you go and use the up arrow key, if you want to, you can take this and paste it, which I just highlighted it and hit enter. It'll paste it down here for you. You can make the change that so we're doing, this is 7, choose 2, and 6, choose none, over 13, choose 2. It might save you a little bit of work. All I did was make the change. You can also plug it in just like before, but this one was very similar. So you can always go in and modify it if you want to do that, save a bit of keystrokes. So there's my decimal, 0.2692. Math, convert to frac. So you go math, convert to frac, 7 over 26. So a little bit more than the last one, okay? So here we go. We have, let's see, I've got, this is equal to 7 over 26. And that becomes, this was equal to 0.2692. So let me put this in a text box. This is equal to 0.2692, which is equal to 26.92%. And that's how we get our second answer. Okay, let's take a look at part C of the question. I'm going to continue on here. Let's go back and share the screen. So here we have the probability that 1 man and 1 woman are hired. 1 man and 1 woman, part C. So now you say, all right, here's, you're going to do a probability. This is going to be the probability. This is number 3C. And we're doing probability that one man and one woman are hired. So what do we want? We want the number of ways to hire one man and one woman. So we're going to say that. So we're going to write this. We're going to say, this is the number of ways to hire one man and one woman over the total number of ways to hire two people. Okay, so in this case, this is going to be, I need a longer box than that. Okay, there it is. So I'm looking at the number of ways, to hire two people. Again, let's do this. So we have probability of hiring one man and one woman. And we should find the number of ways to do that. So from the 6 men, you choose, so from the men, we choose 6. So we get this. Remember, we had 6 men and 7 women. That was our distribution. That was a total of 13. Okay, 13 total people. So now we're going to say, there we go. All right, so here, I'm going to say this. From the 6 men, I'm going to hire one of those. So 6, choose 1. Times, this is and. So here, we're multiplying. So we're times. And from the women, we hire 1. 7, choose 1. Which we did before. And of course, the bottom remains 13. Choose 2. So 13. Choose 2. So let's do this calculation. And let's see what we get. I'm going to put in our numbers once again. This time I'll do it from scratch. So we're going to have parenthesis, 6, math, probability, NCR, 6, choose 1, times 7, math, probability, and CR1. That gives you that. Then you divide that by open parenthesis 13, math, probability, and CR2. And hit enter. You get 0.538485, actually, if you round, 0.5385. I'm going to go to math, convert to frac. Oops, I went to math probability instead. Math, convert to frac, 7/13. Okay, so you have almost a little more than half, a little more than a majority that you'll hire one of each. So remember, if you're rounding this 4 has a 6 behind it, so it becomes 5. If you want to set your mode to 4 so that it will round, you can. But if you do that, it won't show you the fraction properly because it will truncate this, okay? So you can have it show you now. You can go to mode. You can go to float. You can go to 4. And then you can hit enter and then quit. And then go back to this answer. And it will round it for you, 5385. So now this is going to be it's going to equal text. We have 0.5385. And that comes out to, oh, actually, let me put 7/13 is my fraction here. And this is equal to 0.5385, which is 53.85%. 85%. There you go. Now, most students are able, once you kind of see the pattern, most students are able to get these 3 pretty well. The one that gives people problems, and the main reason I decided to present this problem is part D, okay? Part D says the probability that one man and one woman who are twins are hired. And that's always a little tricky sometimes for students. So let me show you that. So here, okay, we're going to do, I'm going to do part D on the same enough. Okay. So now I'm going to say that this is the probability of one man and one woman who are twins are hired. Now you have to remember, we don't know which group is the twins, but we can assume that there's one group of twins if they're asking us this. Twins means 2 people who look alike. So this is equal to, now, not the number of twins, and that's the trick. This is the number of ways to choose the twins, okay, from the group, not the number of twins there are. So the number of ways to choose the twins divided by, excuse me, line here, divided by the number of ways to choose two people, right? So number of ways to choose two people, okay, who could be twins or not, but this is just choosing two people in general. So we have probability that one man and one woman who are twins are hired. Now, remember, we have to choose the twins from the twins. Now, how many people are going to be in that group? Well, there's going to be 2 people in that group of twins, right? There's 13 people in the employee pool, but 2 of them are twins. So the top of this will be from the twins, from the 2 individuals who are twins, you're going to choose both of them. So 2 choose 2. And here you get, now if you choose the twins, you don't choose from the rest. So that's the deal there. If you wanted to make this mesh, this will be two choose 2, and this is going to be 13 choose 2 below that. So we get, this is going to be 13 choose 2. Okay, so it might be obvious to you, if not, we'll do this on the calculator, but it might be obvious to you that if we're choosing 2 people from 2 people, that there's only one way to do that, because you have to select the twins. But let's do this and see. So let's go to the calculator at this point and see what's going on. So we have, I'm going to go and I'm going to say that this is from 2 people, choose 2 people, math, probability. You've seen me do this a bunch of times. Feel free to fast forward if you'd like. But the top is to choose 2 because we're choosing from the twin. We're dividing by 13, choose 2. So 13 math probability in CR 2. You get that. You hit enter. 0.0128. So a little more than 1%. I'm going to change my mode so I can get the fraction. So go to float and change it. Go to math, convert to frac, and I convert to frac, 1/78. So we have a 1/78 probability of choosing our twin, 0.0128. So here, this is going to be equal to, this is going to be, let me text it. Actually, let me erase this first. Okay, so we have 1 over 78, and that's equal to 0.128, which is if you remember, let me go back here, 0.128. So we have 1.28%. So this is going to be 1.28%. Now let's take a quick look at the keys. So we can, this is number 3D, if you're following. Okay, now let's take a look. We're going to go back to our homework, and we're looking at this one, 0.192, 0.269, 0.538. This is 0.013. Obviously, if you round, she rounded here to 3 places instead of 4. If you round to 3, then this answer, actually, this is, I made an error. I typed this wrong, so let me type it correctly for you. This is 1 over 78. And this is, be careful of your decimal. So this is 0.0128. If you round this to 3 places, the 8 behind the 2 makes it a 3. You get 0.013 as your answer. That's why she got that. Okay. I rounded to 4. The key rounds to 3. You may be asked to round to 3 or 4 places. She normally rounds to 4. So that's what I've done here. In any case, I hope that this video has helped you and that you've learned something more about combinations and using them for probability. And I will see you in my next video. Thank you guys for watching, and I'll see you very soon. Bye for now.